Good afternoon, everyone. Thank you all for being here. My name is Gerie Owens. I've been a speaker for a while. I'm a quality assurance manager. I'm a test process expert. I do a lot of test processes and agile process assessments and create plans for improvements. On the personal side, I'm into fashion design. I'm currently taking a class on that. I enjoy the beach. I live in Boston. I always want to be near a beach. And this picture is in Key West, another one of my favorite places. Cognitive bias. I do want to put a footnote here. This presentation is a compilation of ideas from Peter Varhol and me. We used to speak together before he passed away. So footnoting Peter, he was before his time with cognitive bias. So we're going to talk a little bit about not so much testing with AI, but testing the actual AI. How do we test these systems? And from that, we'll start to look at bias. Is it a thing? Yeah, I'm going to show you that it actually is. We'll talk a bit about how to identify bias, how the systems become biased. Does it even matter? Yeah, it does. And what we can do to test for bias. And then, depending on how the time goes, I have a section of food for thought that has some really interesting stuff. But if we don't get to it, then definitely grab the slides and take a look at it yourself. So how do we test these systems? Well, for one thing, it's a different type of software. AI needs to learn, right? We have to train it. How does it make decisions? It makes decisions based on what it's learned. Then what do we have to do? We have to determine not only do the algorithms work, does the system work, but has it learned correctly? And how do we define correctly? So those are all things we're going to talk about. But let's even take a step back. Let's think about learning. How do we learn? So I had a friend bring her young child to visit me one day. And as soon as he ran into the room, he's just a little toddler. He looks at me, "Cat, this is Daddy." So why did he do that? Well, what we got here? We got a dog, we got a cat. What do you see? He's got 4 legs, she's got 4 legs. They got 2 ears, they both got snouts. Yet one's a dog and one's a cat. So if I think about it, and my friend told me, oh, he hasn't seen a cat. We have a dog. Well, now to put that in the terms for AI, why did he not know the difference between a cat and a dog? He had not been exposed to the data that would show the difference between a cat and a dog. So when we think about learning, we think about whether it is us learning, whether it is our children learning, whether it is AI learning. It's all about learning. Now, just quickly, when we assess the training, now we also have to look at a bug versus a bias. So, we all know what a bug is, right? It's a difference between actual and expected results. We write it up, usually involves a code change. A bias, though, is more difficult because it's more of a systematic inflection into the decisions that produce results that are incorrect and inconsistent with reality. And the unfortunate thing here is that the bugs, the biases, can't necessarily be fixed with a code change. Why? Because it's the learning. And the learning came from the data. So this leads us to the origins of bias in AI systems. But let's just take a quick look at the definition of cognitive biases, because we hear so much about biases today, and people think of them in many different ways. But I do want to read this because it is important. So cognitive biases are systematic cognitive disposition or inclinations in human thinking that do not always comply with the tenets of logic, the probability reasoning and the plausibility. These are intuitive and subconscious tendencies that are the basis of our human judgment for decision. That's a little bit scary when it comes to AI, isn't it? That AI can be out of touch with my. Well, yeah, it can. So let's now move to the origins. Anybody got any ideas of the origins of bias? Of bias in AI? Yeah. People. You got 3 slides ahead of me. All right, nice job. So it came from the data. It was like, my little friend had never seen a cat. Didn't see the data. So bias can be present in the actual training data itself, right? It can also be the measurement of the data. There can be biases in the way that we actually measure the data. There can be issues with the algorithms. But when it all comes down to it, it's human. We select the data, we measure the data, we write the algorithms, and this data that we, as human beings, who all have biases, whether we like it or not, or whether we like to admit it or not, we are presenting the data through which the AI has learned. Now, I know we're seeing a lot of toucans around, but my bird. So why is training AI, a little bit of a joke, but why is training AI like training a bird to talk? Yes, and sometimes it learns something you don't want to. My sister and I had a bird when we were growing up. Yeah, we had a cat too, and the cat sang from birdcage, but that's another story. The cat hadn't learned its place was not on the birdcage. But of course, we were kids. We insisted we clean the cage, but we did not. And my mother had to clean it. She didn't like it particularly, and she'd be cleaning the cage. Dirty bird, dirty bird, dirty bird, dirty bird, dirty bird. So basically, yeah, you're training the parrot, it learns what the data, it learns from the data that you present. So how are we going to identify biases? Well, there are some challenges. Because the problem domain is always going to be ambiguous. Sometimes, and as testers, we always want that actual to expected result. But that's not always going to be the way. I mean, sometimes it's like horseshoes, or as my colleagues in Boston, horseshoes. Sometimes nearly is good enough. But if you're going to decide whether nearly is good enough, what's nearly? What side of nearly is good enough versus not good enough? And we don't always know why the AI is responding in the way that it's responding. But bottom line, we're choosing the data. So how do we actually start to figure this out? Well, again, the big word, data. We look at the data. We have to set criteria in the data. We have to have lots and lots of data. Because this is where you need the edge cases. You need all the possible data that you can come up with. And sometimes when you're running many tests, even just a slight change is going to make a big difference in the results. So we have to be really conscious. We have to think about it. We have to use our human intelligence to determine, is it good enough, or is there a bias? Are you seeing patterns? Remember, a bias is a systemic inflection. So you should start to see patterns in the results that you're getting. And some of these patterns can not be so good. So, we know what's expected. And we put our input through the algorithms. But what happens if the data still systematically misrepresents the domain? Well, let's look at some examples. So one of the biggest ones, and this was quite a while ago, but Amazon. They created one of the first ATS systems, the applicant tracking system. And what this system did was their training data, it was to find IT professionals. That's what they were looking for. Their data was the successful applicants. That's what they used for data. Well, that sounds reasonable, right? Well, all it selected was resumes of men because they had not yet hired any women. And you see that with a lot of things. So how is it that the software becomes biased? Well, there are three types. I mean, there's a lot of types of biases that could be in your software, but some of the main ones are data selection, where the training data had a bias in it, like the Amazon. All the training data was males' resumes. There's an interaction bias, and that is that goes back to the measurement of data. How are we actually assessing what the AI is coming up with, what it has learned? And then there's also a latent bias. And I think Olivia mentioned this a little bit, because the algorithm is incorrectly correlating something, the ideas maybe with the demographics. It is not correlation, doesn't, and the causation, it misrepresents the causation. So let's talk a little bit about each of those. So a data selection, and there again, we maybe did not pick a large enough sample with a diverse enough sample, depending on the type of software. It could be something maybe that has to do with the weather. We don't pick enough different types of weather. There was an example that Peter used to use. They did some kind of a wind tracking thing, but where they lived, he and the other person that was working on it, the winds were very different than, say, the Midwest. And sometimes the problem domain can shift. Now, the latent bias, did I miss a slide? No, I guess I didn't. Okay, the latent bias, this is where the causation does not necessarily correlate properly. So just because something correlates does not mean it was the cause. So in this case, it could be something that stereotypes with AI. And finally, the interaction bias. This one, a good example, the old Microsoft Tay. They used the training data for Microsoft Tay was what was on what used to be their social media, and it picked up all kinds of nasty language because people that were submitting posts on this didn't keep their language clean. But the bot wasn't trained to recognize that these were bad words. Now, both this and the AWS example, and also Grok recently, that spewed out all kinds of anti-Semitic language. All three of those, the AI had to be pulled. It was, there again, you know, it got so far in that it wasn't fixable. They had to start again with the data. So, does bias matter? Well, I think in many ways, now it absolutely does. You know, we certainly wouldn't want any bias in a self-driving car, although some people seem to think that autopilot, you know, I mean, you wouldn't want anything to happen there. Our e-commerce, the recommendation engines, well, that can be an issue. I mean, it's not a life or death issue. I have an example coming up in that. Our finance, our staff training programs, digital medicine and health trackers. We sure don't want any biases there. You know, what if you, I also test SAMD, software as a medical device. And I'm working with one now that it's a physical therapy device. You have these trackers, the motion trackers that go on your body, depending on what part you're exercising. There could be differences between a woman my size and say a tall man that the AI might not pick up on. So, of course, why does it matter? Well, because there's wrong answers. And sometimes it doesn't even come up into, it gets to production before that even happens. So at that point, it's basically, as we've seen with some of those examples, it's tear it down. It's kind of too late to do anything about it. It can encourage prejudices. You get suboptimal results, you get wrong results, and sometimes it's not getting it right enough. So, bottom line is all software is going to, because we all have bias. So that leads to, how do we find it and correct it? So again, you know, where do we start to correct? Data. We have to know, you know, we have to use the data of the problem domain, but we need lots of them. We need lots of data. We need different kinds of data. We need the edge cases. We have to fully represent the problem domain. But sometimes the data is going to be contextual, and that's something that we have to watch. So, like say a recommendation engine, that's a good place where often you take the context isn't taken into account. I'm a runner, and I personally don't. Runners are pretty specific about their running shoes. You know, you usually have a certain brand, and you like certain brands, and you don't like other brands. And I have a friend who was a runner, Peter, actually. He liked the Brooks Ghost. That was the name of the shoe. Running shoes, the manufacturers of running shoes give these weird names to running shoes, and I don't know what a ghost has to do with a running shoe. I don't know, but that was Brooks's name. Now, I went on Amazon to order him a pair for Christmas, and cool, I got them ordered, and then it asks me if I would like an ultraviolet flashlight, if I would like a hood, maybe I'd like a book on ghost hunting. Yeah. So, okay, was there harm done there? No, I thought it was pretty funny. However, if they'd offered me a choice of a singlet, maybe a pair of running shorts, maybe the latest new socks, I might have purchased. I didn't purchase an ultraviolet flashlight. So let's get a little bit further into the testing here. You know, we have to, the challenge there is how do we determine what's good enough and what's absolutely not good enough? And how do we determine that when the results change from each iteration? That can be a challenge. The results are going to be different every time. And how do we, again, it's going to come to is what are we going to determine as bias? What's our definition of done? What is our requirements what is our requirements regarding bias? We need to, we can say we need to have objective acceptance as objective as we can. We need tons and tons and tons of data and more. Our results aren't necessarily going to be accurate, but we got to use our own head and realize that, something that may, like the recommendation engine, it picked up the word ghost, gave me ghost hunting. Well, technically, if you look at it that way, you could say that's right, but we know that's not right. So you need to really get your eyeballs on it. And the thing is too, you need to understand the architecture and understand the algorithms, because that's where you'll pick up on stuff like that. And then you need to be able to, it's kind of difficult to communicate the results based on our traditional metrics. It's more a level of confidence. And what level of confidence do we have here? What level of confidence do we have that we're not going to be insulting somebody or not including resumes of very qualified candidates just because their demographic was not included in our test data. We really have to use our head. So jump to the next one. Our test approach, we need to think outside the box. We need to, what's a real user going to do? This is a big, it's big. And especially when you're looking at bias, is how is a bias showing up in your app? How is that going to impact your users? How are they going to feel about it? And if they could feel pretty badly about it. Lots of edge cases. Run many tests. You need maybe a more holistic review of your bugs, because as we talked about in the beginning, there are bugs, there are biases. And we got to understand just where we're going to say, okay, this is maybe not quite right, but acceptable for now. This is no way. So in our testing, we need, again, requirements. We need to have full definition in our requirements. Personas are a good way of managing biases, because a persona do everybody use personas in testing right now? It's a really good way to get the human experience in there, because a persona is basically an archetype that's built on a person. It's their demographics, their education, their what they're going to be doing with the app, and that can be a real good way. You want to include that's going to help you say, you know, that's going to help you say that your expected, your actual result does or does not. You know, you can't just say does or does not match. You need, it's got to be within the range. And again, lots and lots of data. So when you compare your results, is it a consistent match? Does it meet the goals? I think that's really the key here. Does it meet the goals of the project? What Olivia was saying. Does what you built meet the goals? Does it not upset anybody? Is it fit for purpose? Is it going to work for our customers? Is it reflecting our values? Is it reflecting our personal values? Is it reflecting our organization's values? That all needs to be considered. And if it doesn't look right, new data. Maybe we have to clean out all the test data and start all over again. Better that than have a Microsoft A or broke or something, you know, that causes a big problem in production. So again, in your bug review, you have to look at the bug versus the bias. And if it's a bias, it could involve serious redevelopment. So plan it, and that comes to planning your schedule. Make sure you allow a lot of time. And maybe your boss isn't going to want to hear that, but yeah, you need a lot of time. And most importantly, it's about, bias is about real. So you need test data that uses real life. If it's not you know, a life-threatening type situation, you know, it's not something where people could die, consider putting it in a small canary release just to see how it goes. And make sure the humans are right there and can validate what's going on. That's really the big one. How are we on time?
Yeah, about 10 more minutes.
Perfect. Then we'll go ahead and do the food for thought. So bias, truth, and AI. Remember, all human decisions are biased in some way. Now, do we want human decisions, or do we want correct ones? It can be a little bit of both sometimes. In Gemini, Google Gemini, at one point they had some data in there that I think they were showing the different presidents, the statue, you know, the ones that are in the rocks. They were giving them people of different nationalities. It was, you know, it was trying to incorporate DEI, but then that's the question of, is that accurate? You know, what can we get? Can we get human decisions? Can we out of our software, or is it better? In that case, it probably wasn't better, but it's something we need to think about. Bigger problem. AI? Do we want AI to replace human intelligence? Do we accept some bias if it's consistent with human decision-making being biased? It's not an easy question. There aren't easy answers. It's something to think about. And I think we have to keep humans in the loop. We may not completely understand the complex software, but when do the disasters happen? It's when the software behaves in unexpected ways. Human oversight can prevent these disasters, but can we overcome the bias? And the other problem is And this is again why we have to get a lot of testing done up front. Machines respond fast. So even if we see it, are we quick enough to fix it? Maybe, maybe not. So in conclusion, you can't make intelligence from code. Intelligence, AI intelligence comes from data. Remember the little boy? He had never seen a cat. He did not know cat. Algorithms can't actually think like people. Our learning systems are what we put together, what we train, and there are really no easy answers. We choose the bias, we choose the data, it's likely to be biased. But the point is, we have to recognize that, and we have to get the right data and much of it into the problem domain. So it's about choice. There are a lot of choices when it comes to bias and AI. But choose wisely. Thank you. Okay.
Because we're during the testing. Question was two-part. Can you further expand on understand the architecture algorithms, prompts, and B, will we have access to train data or how this?
Well, I think as far as the prompts, yeah, I mean, we need to work with the developers to fully understand the architecture and the algorithm. And if we don't understand it as a tester, we need to pair with the developers. And what was the other question? Data? Yeah, well, we're the ones that should be if we're not the ones that are creating training data, we certainly should be, again, pairing with the prompt engineers. We should be it's kind of, we should be working with them in order to make sure that we get the right span.
Well, if we're using models that we didn't build, we don't have access to the training data. You're talking about language models, the volume is so large, it would be not that useful to us.
Mm-hmm.
So and then also generally the training, if you are building your own models, your training data, your test data should not be included in the training data. You should have separate sets of data for testing versus training. And a common practice is that you take whatever your data set is, set aside a set of techniques you might have otherwise trained up and used for testing.
Well, if you do that, you're not going to get as much of an opportunity to find the biases, right? I mean, if you're just taking a subset of whatever's been trained on.
And then I have well, we had another same thought, so you can remove my code. Okay. Thanks. I think it's a really good question. As we are doing model-based testing and development, there is a and the unfortunate thing right now is the training data is the test data. So because either they have smart tools to build data automatically, somehow be more smart that this training data should not be at all equals to testing. And that's what the companies who are building models are struggling with. They are not having enough test data for the right test data to validate the bias and so and because there is lack of data to both the sides of it, basically it's like about that's I think the core reason why we see so I was actually meeting someone who was using AI to test performance, and they said, you know what, I want to test my system at scale using AI, but I have only this small little test that will do it, then I just told them, right, why don't you use AI to, get this set of questions and ask them to generate a lot of questions. And that actually opened up more gates for them. But then again, this was based on that set of data, which in your case would be that set of training data. We are going to use for testing.
Yeah.
So, yeah, and Microsoft actually has a full testing body on it because it's the right team. They can just be this. They don't look at it better. It's just right. So basically, they're testing.
I think the large language model, it kind of, it expands the problem. It makes it more complex in a way to find bias.
A little bit of follow-on and maybe a little bit new, but the question is, if we're not building models, but we're using AI-driven tools to solve, and if our testing applications use AI as part of their solution, and that testing team is responsible for validating the solution that they're building, but they don't have any access to the model. How do you adjust when recognizing whether or not there's bias in the model for your application, what you care about?
Oh,
If you didn't actually construct, it's not testing the model itself, it is
You're-
you're building an application that's using that model, and then it's still a problem to deliver some value to your customer.
well, there again, I think you gotta really use it. You have to look at personas, what is your application? What is your application for? How is the data that you're seeing? How is that gonna impact? How are your customers gonna feel about it? Do you see any potential bias issues coming through? And yeah, then how do you fix it? That's the next question, I guess. If you find it.
I can also see a case where you're trying to evaluate which model to use within your application. How would you evaluate the potential bias in one? Potential bias in the other?
Well, they try testing, see what results, if you can do like a POC with each of them and see what the results look like and compare.
Just to address your comment there in the back about which model to use, maybe just consider suitability for purpose. I'm reminded of the experiment that MIT, I think, produced 7 or 8 years ago with the Norman AI. You guys familiar with that in general? So MIT ran an experiment in which they trained 2 different AI, one on a set of standard training images for image recognition, and one on a particularly nasty set of images from a subreddit. And this second AI was an absolute psychopath. And what they did to test both of them was they gave them a set of the Rochefort ink blots that psychologists used and asked the AI, what do you see? And the friendly AI would come back and say, I see a girlfriend sitting on a park bench. And the other came back with, I see dripping blood from wires of the dead eagle and other nastiness. So if you're choosing between 2 models, I would just say, look for the suitability of purpose, go back to your concept of operations and ask yourself whether the AI is giving you suitable responses for what you have for operational concepts.
Yeah, I think that's where you need a bit of a POC to get that. Yeah, absolutely.
I'll say, so there's if we're using one of the foundational, language models, there's the bias of the model itself, and most of the makers or providers will provide, benchmarks that they've done about bias. It may not be in their marketing, it doesn't mean that it focus whatever makes them look better than the others, but you'll find either the companies produced it or some researchers have done some benchmarks on it. But then when it comes to our specific applications, model is either we built or we're using somebody else's in the general purpose code, but once we fill it to our specific use case by using it for the other data, and that's really making more chance that applies to the show up. So it's mentioned in one of the other talks earlier, it's very important to also test for our specific use case.
Right.
And when it comes to testing using AI, usually the terms will hear is either benchmarking or evals. And these are basically, we need to not look at as we for our normal test cases, it's clear pass or fail, but how can we evaluate in a more granular scale of how desirable or undesirable something is. Maybe there may be absolute, limits to where we say this is undesirable. And often it's, if you have a simple thing like answering the factual question, those are relatively easy to benchmark. We create a bunch of questions and expect the right answers. It becomes more difficult when you get into more intractable problems. Right? I love the example of doing the ink blot test that you train two models and get that. It's an indirect thing, but it is something where you can now use a model to test the model by seeing what it comes. You could have some evaluation that's looking for, certain terms. You also need to be careful that a language model could say something is something or is not something. Just look for a keyword match. It's going to match either. But this is one of the challenges, figuring out how can we evaluate this. And
Yeah.
There are some existing benchmark factors that we can adapt for your use case based on whatever sort of bias you care about. But it's basically find whatever your task is you want the AI to do, the set of inputs, the set of expected outputs, and evaluate. And it doesn't need to be perfect. Also,
Right.
you don't want your benchmark to score 100 because then you can't measure proof. But that enables that comparative analysis.
Yeah.
Different versions of prompts or different versions of code that
Yeah. Yeah, that makes a lot of sense.
Yeah. I worked for, they were trying to evaluate between two different models that we're considering, and the outputs were very ambiguous, very subjective. It's good output or bad. So we really weren't tell what a bias was. It was just like which one has fewer questionable results. So it's kind of going, but what less of that.
Well, yeah, and that's where the training comes from.
Yeah.
Yes.
So this may be completely off, not very useful, but there's at least a century of research that people are trying to find through numbers, not just the large language models. And there's this thing called an RCT, a randomized control trial. So if you've got a drug you want to give to somebody, first of all, it's got to be randomized. Can you identify the demographic properties, sex, age, blah, 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 and try to get those uniformly represented? That's number one. Second is if there's a control, somebody gets the effect, somebody doesn't. And it's a double trial that nobody knows. And it's a single trial only one. And that body of knowledge is really well understood, even including a number to measure the bias. It's got a great name, it's called kurtosis. And so I'm wondering if there's anything that can be done to learn from that research process that might help us identify and limit the bias in the training.
I think it could have potential. I think there would be potential there. Yeah.
It doesn't matter. No, not so much a question, but, when you were talking particularly about the, Amazon bias, it reminded me strongly of a Dune quote, which is a sci-fi book that, famously doesn't have AI. I couldn't find the exact quote, but it goes something like,
My very real human flaws are amplified by the number of people who follow me. And it makes me think a lot about, how important it is to identify and fight bias in AI because, a very small number of, researchers and developers can create an AI like, a large language model, ChatGPT or something like that. And a much larger number of people will follow that, unquestioningly often. And so, as testers, it's super important for us to try to, find those flaws and squash them as much as we can.
Those 240,000 likes must be true.
Yeah. But it's definitely, it's a topic that, yeah, we don't even have all the answers yet. I wonder if we even have all the questions. But it's definitely something that we need to keep thinking about and keeping open to. And you wonder too, I mean, how many of these big ones that have happened, the ATS, Gonk, but how many smaller biases come out in the social media that aren't picked up on, but maybe subconsciously impact? Yeah, 247 million likes, it's got to be true. When, yeah, there really isn't. And I think a lot of people don't necessarily think when they think about the validity of what they're reading or watching.
Then if we train AI off all those thoughts, it would be important. Yes, and I want to say thank you. A lot of people may think the models and take on that, but it takes our bias, which you might think, just now, wow, it's 16 years ago, Jonathan Cooney, who wrote the book Turning Numbers into Knowledge, keynote cast. And one of his key things with a keynote in from his book, it says there's always a value check. Often people try to use numbers, they have that objective metric, they're objective because of the numbers, but there's always a value that involved in what data that's based on. The same applies to the analytics. The value judgments in what's included, value judgments and grading that data is value judgments and interpretation. So just because it's math doesn't mean it's
Right. Well, thank you all.
Thank you.
Thank you all for your great participation.